So hi everyone, um, welcome to the second video. So in the last video, what we have learned about the DDoS, the basic idea I have given you regarding the DDoS, and also I've explained how the web DDoS protection help us to prevent the DDoS attacks. So now in this video, what we will learn like the DDoS protection components. So if we will take any uh, DDoS protection tools which will protect our network from the DDoS attacks. So what are those? There are many vendors in the market from where you can take this type of protection for your organization, for your organization network. So like I'm going to take the example of Radware, which is one of the organization which is providing this DDoS protection. So in the DDoS protection, basically they have four major tools. So they have basically four major tools. One is the flow detector. The second is the defense flow. Then they have defense pro and the AP vision. So flow detector is basically, you can say it's a kind of a flow collector. Okay, it's a kind of flow collector and it collects all the traffic from the routers. It collect all the traffic from the routers and and then it will send the traffic to the another component which is known as the defense flow. And in the defense flow, it is actually a VM, and which is a virtual machine. It's an automation tool. It's basically an automation tool, and it is used for the diversion. Okay, it used for the diversion. So whenever this flow collector collect all the traffic, whether it is dirty, whether it is clean, all type of traffic, it just collect and then it's sent to the defense flow. And here defense flow will see it will distinguish between the clean and the dirty traffic, and accordingly it will divert the traffic to that device which is going to mitigate those dirty traffic. So here it push the policies to the defense pro. It push the policies to the defense pro because it works. Obviously it's a kind of automation tool. So what kind of automation is there behind its function, or what is the principle behind that defense flow? Is actually it it basically use the policies. Okay, there are the policies, and according to those policies, it help to divert those traffic to the um, to that particular device which is being assigned to collect the traffic. Then we have the defense pro. Defense pro is basically, you can say it's a kind of a scrubber. Okay, and it mitigate the traffic. It mitigate those attacks, those dirty traffic. It mitigate and it send the clean traffic back to the network. So it drop the malicious traffic. Main functionality of this component is this: it drop the malicious traffic. So in the next slides, we will see how it drops the malicious traffic. And obviously we will see the defense flow also and the defense pro also. And the last is the AP vision. AP vision is the manager. Okay, it's a VM, and it's a manager, and it's managing defense pro plus defense flow. It's managing both these devices. So this is the overall summary, just overview of the components which Radware is providing for DDoS attacks. Okay, for saving us from the DDoS attack, for preventing the DDoS attack from the for the organization. So we are using Radware components. Okay, so let's see one by one in depth what is defense flow detector, defense flow, and then the AP vision. So first is the flow detector. So as I've told you, like flow detector is nothing but it's a kind of a flow collector, and it collects the traffic. It basically collects the traffic from all the routers. From all the routers, it collects the traffic. Suppose we have a number of routers which are configured in that flow detector. So it collects the traffic from all the routers like this. Okay, so it collects the traffic from all the routers, and it's an extension of Radware defense flow, which provide the visibility into the customer network, and it's also provide the ability to detect the DDoS attack, and then it mitigate those attacks through the defense flow core logic. So there, the core logic, the policies are applied on the defense flow, and from those policies, we basically push those policies to the defense flow, and accordingly, this full mechanism would work. I have a topology also in the for the slides. You can able to correlate the things which I'm telling you in this session. Okay, so the best way to observe the DDoS attack without traffic interception is by inspecting the network metadata. So that layer 3 and 4 actual session flows from the control plane. So the network metadata is actually, inspect the network metadata. Network metadata is nothing but your source IP, your destination IP, your protocol, port, packet size, count, timestamp, byte transferred. So all these kind of data comes under the network metadata. So if you want to observe the DDoS attack, so the best way, without any traffic interception, just inspects the network metadata. Okay, and once you will inspect that network metadata, you are able to see, okay, there is some variation or there is no variation, and accordingly you can identify whether there is a DDoS attack or not. So all those, like all standard routers expose traffic flow metadata, basically, and Radware defense flow detector, basically this flow detector analyze and it send the data to the defense flow, and then defense flow use the data to detect anomalies and incoming DDoS attacks. So if I say about the key features of the flow detector, so main key features of the flow detector are, first, it's a virtual flow based detection device and it detect attack on a customer infrastructure. It's a complete integration with Radware defense flow, and it's part of new partnership with FastNetMon, and it's a software only product. So you will say, first, the main question is like, whenever we have a flow detector, then the flow detector should be integrated with the defense flow, okay? Because it just it's doing nothing but only the collection. And after the collection, it will go to the defense flow. And the defense flow is basically the device where the traffic is distinguished, whether the traffic is a dirty traffic or it's the clean traffic. How? By inspecting the network metadata, as I just told you. So Radware is also a partner, have the partnership with the FastNetMon. And FastNetMon is actually, it's an open source DDoS monitoring tool. Okay, it's an open source monitoring tool, and it detect and mitigate the DDoS attack in real time. It is primarily used by network administrators and security professionals to protect network and infrastructure from different types of DDoS attack. So this is what are the main features of the flow detector. And apart from this, you can say it has the ability to detect malicious traffic flowing into your network. Then it has a flexible detection engine with DOS or DDoS attack types, and like you can say amplification, floods, attack on TCP traffic, attacks on IP protocols. So it has flexible detection engine. Okay. And third is very fast detection time, 1 second for S flows and port mirror mode. Okay, so it's the detection time is very fast detection time. So with the help of these good features, it help us to detect the DDoS attacks and then able to transfer the data to the defense flow, and then defense flow, then defense pro, and it work accordingly. Okay, so that is about the flow detector. So let me tell you like how it works. Okay, so how it works. So first is um, this is the flow, you can say. So first, it detects attacks on a customer infrastructure using network telemetry statistics, which is the metadata, network traffic metadata. Then alert defense flow whenever attack commences. Okay. Then it will determine the right mitigation technique through workflow engine. And then it eliminate the false positive defense flow behavioral mitigation. So this is the full steps of mitigating any false positive issue. Okay, so this is one by one. So what we have learned right now, we have learned the flow detector, and flow detector is integrated with the defense flow, means we have learned till here. Okay, then there are many other features also. It has the out of path detection, it has the fast detection, flow collection and reporting, it has flow collection and reporting, it has a single plane of glass, good scalability, and it support the many protocols. See there, it support many protocol: NTP, DNS, SNMP, GRE, TCP, sync ACK, flood, UDP. So it support many of the attack types. Okay, so this is about the flow detector. Now I'll show you an example. See, this is the one of the page in the absolute vision, and absolute vision is the manager, and under the manager we basically manage the defense flow and defense pro. Okay, so I just let me tell you like how to configure the flow detector thresholds. Okay, so if you go here like flow detector thresholds in the security settings, when we go here flow detector thresholds, we have to give the thresholds. Like for the TCP activation, we have 20 Mbps. For UDP activation, we have 10 Mbps. And then we have set total activation 100 Mbps. Okay. Then we have set the flow detector thresholds. Now the flow detector is configured automatically. So the thresholds which I have just given in the GUI, similarly, it will append on the CLI. We can see here on the CLI as well. To threshold Mbps 100, then threshold TCP 20, and similarly for UDP, it's 10. So threshold set at defense flow. Now check if defense flow receive flow data. So with the help of these commands, we can see whether the flow detector is receiving the flow data. Now, you can see here, if we click on the flow detector, now in the flow detector, we can see the traffic which is coming under the flow detector. So this is the traffic. It is starting increasing from 952 and it's increasing. Okay, so means we have analyzed the pattern, okay, that the traffic was very low before this time, the traffic was low, and suddenly after 952 the traffic is increasing, means there might be something which is suspicious. So we have to investigate it. Okay, so like this we can just analyze whether there is any attack or not. So now see, you can see here. So the protocol is UDP, okay? If I come to this page, what value we have configured for UDP, it's 10 Mbps, okay? 10 Mbps. But the volume which is coming is 15.8 Mbps. 15 point means it crossing the threshold. So if it's crossing the thresholds, obviously the flow detector will detect an attack. It will detect an attack and it will give us an alert. And then the engineer will investigate why this sudden increase of traffic is there. So in this way, we can suspect the DDoS attacks. Okay, this is about the flow detector. Now just come on the defense flow. Now, Defense Flow is a software product and it leverages network technology and the Radware attack detection and mitigation technologies to provide attack mitigation as a network traffic. So Defense Flow basically act as a cyber defense control plane, and it collects and analyzes various security telemetrics. And based on this information, it provides various intelligent security actions. So, like together with Defense Flow attack mitigation device, Defense Flow provide a comprehensive and a programmable network-wide security solution. So if we see the major Defense Flow key capabilities, so these are the major key capabilities of the Defense Flow. So we have the network-wide DDoS protection. We have automatic attack mitigation here. We have multi-vendor attack protection, SDN-based security, scalability. So these are the major features, or you can say the Defense Flow key capabilities. And Defense Flow support always on and hosted customer protection use case for service provider and to provide the widest DDoS attack defense. Okay, so we have the attack mitigation pillars, and under the attack mitigation pillar is we have detection, mitigation, and the operation. So in the defense flow, we basically detect. We in the flow detector plus defense flow basically detect. Okay, and it detect the attack, and then it will send it to the defense pro for the mitigation. So it happens like this. It happens like this. Okay. Now, let me explain you what is the protected object life cycle. It's very important what is the protected object life cycle, and what is the main motto behind this means defense flow. So we have a life cycle and it's like this process, then this process, this one by one. So suppose the attack is detected. When the attack is detected, then and how the attack is detected? Attack is detected during the peacetime monitoring. Peacetime monitoring I have explained in the first video. So if you're not able to correlate or understood what is peacetime, and please refer my first video, you will be able to. So we have the peacetime monitoring, and under the peacetime monitoring, we just detect the attacks. If we detect any attack, then it goes to the mitigation device for attack mitigation, and then it after the attack got mitigated, it back to the normal, and again it will do the peacetime monitoring. So this is the basically protected object life cycle. What is protected object? Let me explain you. Protected object is nothing but they have defined a policy. Okay, they have defined a policy. You can say policy, or you can say the threshold. Okay, they have defined the threshold for different parameters, and if if the traffic would cross that threshold, then we get an alert, and with the help of those alert we can distinguish whether it's an attack or not. So just to understand this very good example is showing here. So suppose we have this is the operation and this is the attack bandwidth. Okay, we have three triggers: trigger one, trigger two, trigger three. Trigger one is on if there is a one first trigger, then the traffic would divert to PE mitigation. It's already defined. Okay, it's defined according to the values or the thresholds defined in the defense flow. Then if the traffic divert to if the trigger second would occur, then the traffic divert to SC mitigation. SC is scrubbing center. And if there is a third trigger, then it should go to the RTBH. Okay, then it go to the RTBH. So um, what is RTBH? RTBH is nothing but the remotely triggered black hole. Remotely triggered black hole. Okay. So it is actually the remotely triggered black hole it's a powerful technique used by the network providers to mitigate DDoS attacks. So it's a kind of a virtual shield, you can say, and it effectively block malicious traffic before it can reach its target. So it basically blocks the malicious traffic. So now if you can see here, we have the three triggers, and for all the three triggers, we have given the operations. Okay, this trigger, then this operation, this, then this. This you see the example. Suppose the attack bandwidth is 1.5 G. Okay, and there is a trigger one. Attack bandwidth is greater than 1 G. Attack trigger two is greater than 3 G, and if it's greater than 5 G. So if the traffic is coming and the attack bandwidth is 1.5 G. So means it's greater than 1 G. It comes under this category. So if the trigger one would occur, then the operation is being defined divert to PE route, PE mitigation. So type is divert and mitigate. Router group should be PE router. Mitigation should be TEP PE. So in this way, the protected objects would work, and according to the thresholds, the trigger would be there, and accordingly, the operations will perform. Okay. So as we have learned in the last slides, three steps would be there: detection, mitigation, and the operation. Now, till now, we have learned about the flow detector and the defense flow. Now I'll tell you defense flow. It is very important components, very major component. Okay, it's one of the major component. So in the defense flow, basically the mitigation would occur. Where the mitigation would occur? Mitigation would occur in the defense flow. Because because as I told you, defense flow would just, flow detector just collect the traffic. Then the defense flow would segregate the traffic and then do the diversions and it drop the malicious traffic. But the actual mitigation is occurring on defense flow. Okay. Actual mitigation is happening here. Okay. So let's take an example. Suppose this is our network and we need to secure this network. So we have a flow detector, and we have some routers, say R1, R2. So routers are connecting with the internet peering. So the traffic is coming from the internet pairing. It goes to the router. Now the router traffic is first going to the flow detector. Flow detector is collecting all the probes from the router. Then it's sending to defense flow. And then defense flow is sending the data, sending the traffic to the defense pro for the actual mitigation or actual mitigation. So the dirty traffic would enter here and then it send the clean traffic back to the network. It send clean traffic back to the network. So this is the basically example which I have given, and this type of example are there in are there with many operators, and many companies are following this kind of topology. Okay. So one more thing I just want to tell you. So Defense Pro will be connected directly to the edge routers to provide the local mitigation. So whenever the attack occurs, the edge router will just receive a BGP advertisement to redirect the traffic of the specific network under attack to the Defense Pro so that the mitigation is performed. So with the help of the BGP advertisements, the redirection, the traffic diversion would occur. Okay. So BGP is using in many such cases for the traffic diversion. So now the last component is the absolute vision. So as I told you, absolute vision is nothing but the manager, and it's manage the defense flow plus defense pro. Okay, so it's a kind of a device, and it used for the overall management and monitoring. Overall management and the monitoring. Okay, this is like this. Okay, now let me tell you an example. So I have an example here, and where you can able to correlate the thing which I've explained you. Okay, so you can understand like this. Suppose we have 4 data centers, and per data center there will be a defense pro connected directly via the routers. This is R1, R2. Similarly, we have R1, R2 here also at this data center. Similarly, here also, here also. And in this manner, during an attack, the traffic will be rerouted to the defense pro, okay, avoiding attack traffic from entering the data centers, major data centers during the mitigation phase. So there will be a central defense flow, okay, and it has the redundancy. See, we have a defense flow here also, and these defense flow are in active standby. It depends how much the organization wants to invest on the infrastructure. So in this example, we have an active and the standby redundancy. So the defense flow cluster is configured to use this flow detector as attack detector. So this is the attack detector. Okay. So flow detector receives the net flow from all the routers in all the data centers, and it signals the attack to the defense flow. It signals the attack to the defense flow. It signals the attacks to the defense flow. Now, defense flow cluster will be connected to the defense pro. Now, it's connected with this defense pro, okay, via the management network, providing the information needed for the mitigation of an attack. So finally, the defense flow will connect to all the routers to instruct the routers via BGP to route the traffic to the defense pro. So they are also internally connected with the routers in case any attack is detected. So that's why they are internally connected, because if the defense flow will connect to all the routers, then it able to instruct the routers via BGP to route the traffic to the defense pro. Okay. Now this absolute vision is the central appliance, and it installed in a cluster configured as it active standby. So it is the active, it is a standby. In this way, we can configure. Okay. So and the defense flow connects to all the defense flow and to the defense flow via the management network. Okay. So absolute vision basically communicates with the flow detector using REST API. Okay. It's connecting with the REST API to the flow detector. So this is about example of one of the topology where we can see these components and it helping the network to get secure from these DDoS attacks, as it will hamper many things, and better to save it from save from it. Now I'll tell you an example of the DDoS attack category. Okay, so we have a different attack categories. We have different attack categories. There must be intrusion. There can be a DoS. There can be a behavioral DoS. It can be anomalies. It can be DNS flood, HTTP flood, sync flood. So many attack category is can be there. Okay, and this component is segregating all these kind of attacks category into the risk priority, whether it's low risk, it is of medium risk, or it is of high risk. Suppose if we see A is the anomalies, and the DNS flood comes under the low risk. And B is the behavioral DoS. Behavioral DoS will major impact on the network, so it comes under the high risk. Okay, so let's take an example. So see, in this video, I'll explain you about the intrusion. I have taken the example of the intrusion, and like we will see how the intrusion will detect and how we can mitigate those intrusions. Okay, so what I did, I took the data from last 24 hours. Okay, I took the data from the last 24 hours, and I saw, okay, there are 3 types of attacks. Means there are 3 types of intrusions which I have found in the network. So one is the MAMK server reflect, second is the HTTP Apache log4j body 6 RCE, and third is the anomaly TCP reset data HTTPS. So when I have investigate more, I saw MAMK server reflect has the major impacts. So let us take an example of one of the intrusion, and let's go deep dive into that. So first of all, let's learn what is the memcache server attack. So this is the signature mitigate the participation of memcache servers in memcache attacks. Basically, a memcache attack is a type of DDoS attack. It's a UDP-based amplification attack, okay? And it's a general purpose distributed memory caching system and which is used to speed up the dynamic web application by caching data. So you can say it's a kind of a server, memcached is a server, and is used for caching your data and objects into RAM. Okay, and exposure of the memcache protocol to the internet allow attackers to exploit this protocol, and we need to take major actions to protect against this vulnerability. So first, we need to update our Radware signature file. Second, we need to ensure that the mentioned signature group exists in the active protection profile, because we have different signature groups, and those groups should be there in the active protection profile. So I hope you are able to understand what is memcache server attack. So the attacks which is on the memcache servers are memcache server attacks. Now let us see attack table. So this attack table I have I took from Absolute Vision. Okay, I took from Absolute Vision. Absolute Vision, I told you it's a manager of Defense Pro and Defense Flow. So I took the 24 hours of data and I saw, okay, there are many times we have memcache server reflect attack. See, memcache server reflect attack. Okay, and when I've investigated this source IP, this is the source IP from where we are getting the attacks, multiple attacks. These are the risks, whether it is low risk, high risk, medium risk. And then these are the policies which are implemented on those you can say, there are the different policies which are saving that attack, which are saving our network from those attacks. So these are the policy which is applied on it and it has prevented, and that the action which was there is drop. Okay, the action was drop. So when the traffic is coming from this source IP, my system has dropped that IP, dropped that malicious traffic with the help of this policy, with the help of this Radware ID. Radware ID is nothing but it's a kind of, it's one of the signature. It's a signature, okay? This, because we have a particular ID here, so it's a signature, and with the help of this signature policy, this our system is dropping this malicious traffic. Okay, now you can see, just have a look on this Radware signature 18286, which is protecting this memcache server reflect. So what I did now, there are the many attacks. So what I did, I just filter out the memcache server. See, I filter out the memcache server reflect, only memcache server, and I just took this source IP. Okay, this source IP from where it's coming. I just want to investigate from where it's coming. So when I have investigated this infected host detail, I got the information that this is coming from the China. It is coming from the China. The ISP is the China Net Province Network, and many information I got about that IP. Other information also I got, like this is the email is anti-spam emails, abuse mailbox, anti-spam. It's a spam emails. Okay, it's spam coming from the spam email network, and it's coming from the China. Means the attack is happening from the China. So this information I got from the source IP. Now, before get into deep dive more, let me explain you what is the signature and how the signature are protected us. Okay, so we have the protection profile. Under the protection profile, we have rules, rule 1, rule 2. Under the rules, we have attributes. Okay, we have attributes, and under those attributes, we have the different signatures. So what is rule? The rule is nothing but one or more attributes that define a query on the signature database for Defense Pro to match and activate the protection. So attribute is, it's a parameter. It's a parameter that characterizes what to protect, okay, and or protect against, what to protect or protect against. So that is attribute. So let's take an example. Suppose example is there is a female which is, and the name of the female is Nancy. She is 1.75 meter tall. She is blonde. She is covered by rule 1 and checked against rule 1 plus XY. See, attribute here is an attribute means a female, and the color is blonde comes under this attribute. And here one more attribute we have defined, female, and she is medium, she is brown. So we have the two signatures under the female blonde, female tall blonde attribute 1, female short blonde X. And under this we have only one female medium brown. So when when we are talking about a lady and she's tall, okay, means this signature is fulfilling the requirement, and blonde means this one, correct. And uh, like she is a female. Female is also coming here, and blonde is also coming here, and so height is coming only under the signature 1 and X. So this particular examples will like help us to understand how the protection profile is implemented, and under the protection profiles, how the rules are defined, and under those rules, what are the attributes, and how the signatures are basically implemented for those attributes. So signatures are basically defined exact parameter for detecting which packets are malicious and how they are treated. So that is signature, okay? And each signature have several attributes. They should have several attributes assigned. It depends on you what kind of attribute you are assigning. So let's just see an example, signature protection profile. Guys, when you come under the in the absolute vision, you need to go to Defense Pro, and here you will see the signature protection profiles. So see, under the signature protection profiles, you will see the different rules, different attribute. Under that rule, you have different attributes. Okay. Now, let me show an example, one example. So under this signature protection profiles, we have number of profiles. Okay, we have number of profiles: carrier, corp GW, corp LAN, DoS all. Number of profiles are there. So let us see this one of the example I took, DoS all. So under this protection profile, there are two rules, rule 1 and the rule 2. Rule 1 is threat type. Under the threat type, we have DoS flood, slow rate, vulnerability, and then we have the group complexity and confidence, which comes under top, low, high. So means under this protection profile, we have two rules. Okay, we have two rules. Now we need to see if any rule with this, we just click here and we can see, okay, under this profile, these are the attributes. Now, what you can see, this is the application security. So under the signature profile, under the signature protection, just go to the signatures and you need to go to the application security. You need to go to the application security. When you go to the application security, just search the Memcache server reflect. Okay, this is, I think you can able to relate this is the attack. This example I took for the intrusion example on which we are just seeing this investigation. So when we filter out this Memcache server, it's showing that there is a signature ID which is 18286, and the signature source type is static, and this state signature is enabled. Okay, so you can now correlate. Just go back. When we go back here, just see under the Memcache server reflect, my traffic attack table was showing that this kind of source address is coming, and I am protecting your network, means I'm dropping this traffic with the help of this policy and this signature ID. So I hope the signature ID are able to understand that this 18286 is already there. That's why it's dropping the network, dropping it from being attacked. Now, if you see what is there under this 18286, so see, we have defined the direction. It is inbound and outbound. We have defined tracking type. We need to track all. What is the tracking period? Tracking period is 1 second, means just track that network for every second, under this signature. Okay. Then we have the different thresholds. So activation threshold is 1, termination threshold is 1, drop threshold is 1, and the action is drop. That's why it's dropping that Memcache server reflect attack with the help of this signature ID. Okay, so this is about the signature. Now, guys, you need, if you want that your network is clean, should be clean, or there are no attacks, so you need to keep two things in mind. One, you need to update the Radware signature security files weekly or daily. It depends on you. And we need to signatures are weekly updated, and there should be updated weekly, or it depends, weekly or daily you want to update those signatures. But make sure the signature file is updated, then only it will help us. Otherwise, our network would be prone to get attacks. Now, I just told you about the signature ID, like with the help of that signature ID, how that intrusion is getting dropped. Now, let us see what is the protection policy. Okay, this we have understood. Now, what is protection policy? This is the protection policy, which is protecting the network. And with the help of this, the traffic is getting dropped with this IP address. The traffic which is coming with this IP address is getting dropped. So see, there are multiple protection policies. There are multiple protection policies. Okay. There are multiple protection policies who has different action, either block and report, or block we need to do, or report we need to do. What is the direction of those policies? So everything is there. Okay. So suppose we need to search this policy. Now, why we are searching this policy? Because just go back, just come here. We have a policy HT4LN03, this policy, which is actually dropping the traffic. So HT4, I've just searched this policy under the protection policies, and I can see the action is block and report. The action is block and report. The priorities are giving, okay, and the source network is any, and it going to this destination network, then you need to block and report. So whatever we have defined in the protected objects, or you can say in the thresholds, similarly, our device will do automatically, and it will help us to protect the network. So thank you guys. I hope with the help of this video, you're able to understand the major components of Radware, and you're able to see the MAMCAche server reflect attack, and how our network can save us from these type of intrusions. Not this, there are many intrusions, and accordingly you need to make the protection policies. Accordingly, you need to give the rules, you need to give the attributes, and then you need to define the signatures, and then those signatures would help us to prevent the attacks um, to get enter into our network. Thank you. Thank you so much. Keep listening. Thank you. Have a nice day.